Hello guys, my name is Siddharth and I'm from Chanakya section. So today our topic is about binomial distribution and applications. So introduction to binomial distribution definition. A binomial distribution is a discrete probability distribution of a number of success in a sequence of n independent trials of a binary experiments. So key features, binary outcomes, success or a failure. It depends upon success or failure. Fixed number of a trials. There are n number of trials and constant probability of success is P. So independence of trials. These are the key features of binomial distribution. So binomial distribution formula. So here is a formula to calculate the probability of exact k success in n trials. That is Px is equals to k is equals to nk pk 1 minus p n kp x is equals to k binomial n k p to the power of k 1 minus p power of n minus k p x is equals to k equal to nk pk 1 minus p n minus k, where x is the number of successes and nk binomial nk kn equal to binomial coefficient. N chooses the k. So P means probability of success on a single trial. So 1 minus P means probability of a failure. So binomial coefficient explained. So binomial coefficient is calculated as nk is equals to n not equal to k not equal to n minus k not equal divided by binomial nk equal to divided by fraction n not equal to k not equal to n k not equal to kn equal to k not equal to n minus k not equal to n. So this represents the number of way to select k success from the n trials. So here are the properties of binomial distribution that are mean, variance, standard deviation, and skewness. Conditions for binomial distribution. For a situation to follow a binomial distribution, it must be fixed number of trials, binary outcomes, constant probability of success, independence. Binary outcomes, each trial results in a success of a failure. Independence, the trials are independent of one another. So visualizing binomial distribution. The shape of a binomial distribution depends on the probability of a success, that is denoted as P, and the number of trials, that is denoted as N. If P equal to 0.5, the distribution is symmetric. If P is less than 0.5, the distribution is skewed to the right. If P is greater than 0.5, then the distribution is skewed to the left. The graph example visualizing different distribution with a varying P and N. Coin tosses. So here is an example problem based on the binomial distribution. Quality control in manufacturing problem. So here is another problem based on the binomial distribution. Applications in quality control. Defective rate. Binomial distribution is widely used to model the number of defective items in batches of the product. Example, if the defective rate in a batch is P equal to 0.2 and then sample of n equal to 50 items is checked, we can calculate the probability of finding k defective items. Manufacturing helps company determine the likelihood of a certain number of defective units in the production and excess of overall qualities. Marketing and sale application, direct mail campaigns. The binomial distribution can predict the number of people who will respond to a marketing offer based on a historical data. Example, if 20% of recipients respond positively to an offer and you send out 1,000 mails, you can predict the number of response using the binomial distribution. So sales forecasting. Binomial models help predict how many successful sales will occur from a given set of sale efforts. The medical researches and clinical trials, drug testing. The binomial distribution is used to model the number of patients who will respond positively to a new treatment. Example, if a drug has a 70% of success rate and a clinical trial involves 30 patients, we can calculate the probability of observing case successful treatments. Effectiveness evaluation. In a medical research, binomial distribution helps to assess the effectiveness of a treatment in a clinical trials. Sport analytics. Player performance. If a sports analytics use a binomial distribution to predict the number of success actions in a game, like example goal scored, successful passes. Example, if a soccer player scores a 30% of the time and then the team plays 10 matches, we can use binomial distribution to predict the number of goals scored. Team performance. Binomial distribution can also model the likelihood of winning a set number of games in a tournament or a season. Limitations of binomial distribution. Independence. Assuming trials are independent, which may not always hold the true in practice. Example, events influencing each other's. Fixed number of trials. The number of trials must be fixed, but in some situation, the number of trials is variable. Binary outcomes. Binomial distribution is not suited for problems where outcomes are not binary. Approximations for large n and p not too close to 0 or 1, the binomial distribution can approximately by a normal distribution. Conclusion. Binomial distribution is a powerful tool for modeling the probability of a number of success in a fixed number of independent trials. It has practical applications across various fields, including the manufacturing, marketing, healthcare, and sports. While it is widely useful, it has a limitations that should be understood when applying it to the real world problems. Thank you for the watching. Please like and subscribe.